Thank you very much, professors, Professor Papachouris, Professor Devlete, Professor Daniel, for having us here today. It is a great honor and pleasure to be addressing this wonderful conference. So I was given the difficult task to discuss lithogenesis processes. And probably because lithogenesis is a Greek word, that's probably they gave it to me, and lithos is the word stone, and genesis is the formation. So how stones and what the processes of stone formation are. And I don't need to stress to this audience that the formation of kidney stones is a complex biological process that involves interactions of environmental factors, dietary factors, and genetic factors. But I will not address these three categories of factors because, as you all know, there are definitely anatomic abnormalities that affect the flow of urine, and it might be a medullary sponge kidney, it might be polycystic kidneys that predispose to the formation of stones. And there are definitely genetic defects, such as polymorphisms or monogenic polymorphisms, usually that predispose and cause kidney stones. But the well-known processes is definitely the urine supersaturation, and this is the physicochemical disturbance that causes the nucleus and the following processes. And as Alan Rogers, who unfortunately is not here today, I think, has very nicely painted in this graph, it is clear that these processes we have started many years ago. It is, let's see, which one can I, this one probably. Okay, so many years ago, we only knew three steps in this, the consequence of events. And as time goes by, there are more events to be added, and we have ended up with at least 9 or 10 events, 9 steps in the process of kidney stone formation. And things like oxidative stress, reactive oxygen species, and cell rupture and apoptosis have been added to this extensive list. So let's focus on these changes. The pathophysiology of kidney stones starts in the nephron, and the nephron is the house of the nephrologist, not just the urologist. So we all know that it is mainly the imbalance between inhibitors and promoters that is causing the start, the trigger situation. And then, of course, you have all the next events, which is the crystal nucleation, the supersaturation, the crystal growth, the agglomeration. And in this nephron, you can see, but I will not say more about it, this is the area where the calcium phosphate salts have been attached, and this is where the Randall's plaque has been initially formed. And this imbalance between inhibitors and promoters is something that we've known for many years now, but there are new inhibitors and new promoters that have been added to this balance. And you can see to the left where the inhibitors are. There are glycosaminoglycans, there is chondroitin sulfate, there is heparin, there is magnesium, there are other new inhibitors, and the well-known so far promoters to the right side. Urine is a solution. So what applies in chemistry in solutions applies also in urine. And this is what happens. This is the undersaturated area of this solution of urine. And undersaturation could refer to one of the elements. It could be undersaturation with respect to calcium. It could be undersaturation with respect to oxalate or citrate. And this area, this is the undersaturation area where nothing happens. I mean, crystals might form, but they will not aggregate. They will not cause a stone. And as saturation moves up, we go up to this area where this is the supersaturation area where everything happens. And this is where crystals will aggregate. This is where the stone will form. And already present crystals there that are there in that area might even grow. So supersaturation is the thermodynamic driving force for kidney stones, and it is here to the left. And then there is nucleation and crystal growth. And the next steps, which is aggregation and agglomeration, crystal retention, and finally stone formation, they're considered to be the kinetic processes. They have to do with the flow, and they involve the mineralization, the crystallization of the minerals. But a new player has been added, and this is practically what I would like to focus today. This new player, that is the oxidative stress, which is there, involving also cell injury and cell membrane rupture. This is the new player that has been added to the long last sequence of events. Okay, this might look complicated, but I will take you through just to make things clear. This is the lumen, and these are tubular epithelial cells. Here to the left is hypercalciuria, hyperoxaluria, and hypocitraturia. These are the physicochemical disturbances that shouldn't be there, and together with possible dehydration and a disturbed pH, they cause damage, direct damage to the cells, the epithelial cell which is underneath, and you can see that there. So when these crystals form due to the previously mentioned physicochemical disturbances, and when these crystals are taken up by the tubular cells, this is the enlarged portion here, these crystals are being brought in the interstitium. So this is the lumen, they're taken up by the tubular cells, they're brought in the interstitium. And what happens in the interstitium? The macrophages are triggered and they attack the crystals. The purpose of the macrophages is to endocytose, to phagocytose, to eat practically the crystals and use their lysosomes to dissolve them. This starts happening, and these are the anti-inflammatory macrophages that are involved. But unfortunately, let's say that anti-inflammatory macrophages, after long exposure to these crystals, they get tired. At some point, their phenotype starts changing, and instead of anti-inflammatory macrophages, they transform into pro-inflammatory macrophages. So what happens there? They practically perpetuate, eternally continue the inflammation. So this is where we are. Here are the pro-inflammatory macrophages that continue the inflammation. At the same time, and I'm gonna go just one step forward, this is the tubular epithelial cell from up close. We're talking molecular level, and we're looking at the tubular epithelial cell that is retaining the crystals up here, taking in the crystals. And what happens? These bad things are happening. Reactive oxygen species are triggered, they are activated, they are produced. Also, the inflammasome is activated. And all these things, they start a cycle of activation and triggering of the making new RNA for substances such as osteocalcin, NF-kappa beta, and all the interleukins. So you all know this is inflammation. So the cell is inflamed. What happens underneath? we have all these cell matrices that are produced, apoptosis, and calcifications, calcified particles. So, oxidative stress, calcification, activation of the inflammasome. This is what happens in the tubular epithelial cell. And if we go back, and you go up there, it is not just the cell damage that has happened here. There is also this osteogenic changes. So it's not just that the cell is damaged, but there is also calcification, lots of calcification. These are the osteogenic changes, and matrix vesicles are produced in there. And also, due to the osteogenic changes, there is crystallization, and at the end of the day, there is new modulators and new inflammatory cytokines that are being produced, and there they come. So altogether, this was happening in the interstitium, and this is the plaque of Randall, the Randall's plaque. So how was the Randall's plaque formed? From all these debris from the apoptotic cells, from the calcified particles, from the calcified vesicles, from the apoptotic macrophages. This is how the Randall's plaque happened, together with the calcium phosphate crystals. So this is the Randall's plaque that has been attached here on the this is the interstitium, and this is the papilla, so this has been attached here. So this is how the Randall's plaque is formed. But this is the new theory about the Randall's plaque, not the old theory. This is the new theory. And if we just want to summarize it, it is the reactive oxygen species, it is the oxidative stress, it's the inflammation, it's the transcriptional factors that are activated, and all these bad interleukins are being produced. So this is how stones start forming, and this is the major first part of the lithogenesis process. But then I need to say a few more things about retention, because it's not just to produce, to form the stone, it has to be retained in the epithelium, in the papilla, in the collecting duct. That's the question there. So there are three theories. First theory, it is the free particle stone formation, and the stone is formed down here. This is the papilla. In the second theory, the stone is formed in the Bellini duct. And the Bellini duct, this is in the middle, this is the Bellini duct. And it is practically protruding from the papilla into the duct. So this is the second theory. The third theory, this is the classic, what we've known so far, the Randall's plaque, which, in order to be formed, there has to be a rupture in the cell membrane, because if you don't have this rupture there, then nothing can be attached. The calcium phosphate crystals could be around, but they wouldn't be attached on the epithelium. So these are the three theories regarding the crystal retention pathways. And there is one more theory. This is just a repetition, so it is growth over the white Randall's interstitial plaque, growth over the Bellini duct, Bellini plugs. These are called Randall's plugs as well. The formation of microliths within the inner medullary collecting ducts, and the last one, which is also very interesting because you urologists, we are talking about these things in theory, we are scientists, we're discussing these things, but then you go in and you look at it. You have a much better idea of what is happening in the kidney than we do. So this is the formation in free solution within the calces or within the renal collecting system. And this is what you know, and you've seen several times. These are stones of cystine. And they call these stones Easter eggs. And they are not attached to anything. So the theory about attachment, the theory about Randall's plaque does not apply to all types of stones. And I'm sure you've seen it, I'm sure you know that already. What is new about lithogenesis and stone formation? This is very trendy, of course, the microbiome. And the microbiome couldn't be far away from the kidney, and there's definitely a kidney-gut axis. It seems that these short-chain fatty acids that are the ones that link the kidney with the gut. And when they are produced, we're not really sure whether they increase the production of the reactive oxygen species or they decrease the production of the reactive oxygen species. We're not really sure. Some people think they are inhibitors, others they think they are promoters. But the gut-kidney axis is very trendy, is being studied, and we hopefully will have more information about it. And the last new thing is this nanobacteria. It sounds interesting, nanobacteria, but it's not really bacteria. The wording is giving the wrong idea. It is calcifying nanoparticles. They are called also nanobes because they are very small. They are in a nanoscale. And what do? They are the ones that trigger and are involved in autophagy. So they're also involved in the genesis of stones, but we're not really sure how they are involved for the moment. In conclusion, dear colleagues, this is a schematic representation of the consequence of events, which is evolving, which is getting longer, it's getting larger in every direction. And the truth is that it is being looked at, it is being explored. We're not really sure what is happening, where it is happening. There is a lot of work to be done there. But the main elements of my presentation today, and what I would like everyone to be aware of, is the involvement of oxidative stress, the involvement of calcification, the involvement of the activation of the inflammasome, and these are the main issues that are being explored lately. And these are the ones that, if well explored, and all this immune response, because this is an immune response of the kidney to the formation of the stones, all this immune response, when it will be explored, hopefully we will have some more information and some more weapons in our armamentarium in order to treat stones, in order to prevent lithogenesis, and in order to prevent kidney stone recurrence. Thank you very much.